first law of thermodynamics states that energy can be neither created nor destroyed, but can be transformed from one form to another form. In this example, the light bulb converts electrical energy into heat and light energy. Another example is car engine. It converts chemical energy, which comes from petrol, into mechanical and heat energy. Sun also converts radiant energy, which is from sunlight, into chemical energy and stored in organic molecules. The formula of first law of thermodynamics is delta U equals to Q minus W.
This is the material that we needed for this experiment. For the first cup, we give some heat under the cup, and for a few seconds, we can see that the cup starts to burn. And also we take another cup and give some heat under the cup like the previous cup. And after a few seconds, we can see that the cup is not burning up. So why? So this is because there is water inside it. When the cup was heated, there is heat energy flow to the cup. For the empty cup, the heat supply directly burned the cup. While for the cup filled with water, the heat supply flow into the water and cause convection process in the water. This statement agreed with the first law of thermodynamics, which states that heat is a form of energy, and thermodynamic processes are therefore subject to the principle of conservation of energy. This means that the heat energy cannot be created or destroyed. It can, however, be transferred from one location to another and converted to and from other forms of energy. When the water in the cup evaporated, the heat will start to burn the cup as the cup is now empty.
Hey guys, have you heard about law of thermodynamics too? This law is slightly confusing for most students or engineers. Don't worry, and come on, take a tour and clear your confusion with this video. Why we get older and never younger? Why using a smashed plate could never reassemble itself? There is no such thing as a perfectly reversible process. If someone asks what is the direction of time, we can answer with confidence that time always flows in the direction of increasing entropy. Nicolas Leonard Sadi Carnot was a French physicist who is considered to be the father of thermodynamics. He uses entropy rather than caloric to describe the second law. The formula says that the entropy of an isolated natural system will always tend to stay the same or increase. Refrigerators seemingly break this rule since they can freeze things to much lower temperatures than the air around them, but they don't violate the second law because they are not isolated systems. William Thomson, also known as Lord Kelvin, formulated the Kelvin statement, which states it is impossible to convert heat completely in a cyclic process. This means that there is no way for one to convert all the energy of a system into work without losing energy.
Heat always flows from a body at higher temperature to a body at lower temperature. The reverse process never occurs spontaneously. It states that a refrigerator cannot operate unless its temperature is driven by an external power source such as electric motor. It is impossible to construct a device which operates on a cycle and produces no other effect than the transfer of heat from a cooler body to a hotter body. The most efficient heat energy cycle is the Carnot cycle, consisting of two isothermal processes and two adiabatic processes, where the second law of the thermodynamics states that all the supplied heat in heat energy can be used to do work. The Carnot efficiency sets the limiting value on the fraction of the heat which can be so used. The Carnot energy cycle, when acting as a heat energy, consists of the following steps. First, reversible isothermal expansion. Second, isotrophic reversible adiabatic expansion. Third, reversible isothermal compression. And lastly, isotrophic compression of the gas.
Hi everyone! So, these are the materials that we need. The first one is glass at room temperature. So the second one, we need a glass at a cooler atmosphere. So the last one that we need for our experiment is any cool drink that you want. We need to cool a glass and also our cool drinks in my chiller. So we need to put them almost like 30 minutes to cool them. Let's say I'm a bartender at one restaurant and I'm using a glass which is kept outside at room temperature. But when I put the cold drink into the glass, the beverage will get warmer soon. So I don't like it. I want to gather cold drinks. Oh, I have an idea. If I keep the glass in a fridge at a cooler atmosphere, the temperature difference will be lesser. This means that my beverage will stay cooler for a longer time, so my customer will not scold at me. But note that the beverage will get warm though after some time.
Good afternoon to Dr. Nadia and all of my classmates. I'm Ng Qian Yet. I'm sorry that I can't attend to the presentation today because I'm joining a competition in Myanmar now. And I hope our group can give surprise to all of you. Thank you.